All right, now we're gonna continue on example number 2. Now, so remember the first thing that we're gonna, it says solve the differential equation. So remember, we want to determine the general solution. Unless if we were given the conditions, then we are going to determine the particular solution. In this case, there are no conditions. So now, to determine the general solution of this equation, what are we going to do? Simple. Set up the complementary equation. We have 2m squared minus 2m minus 3. So we have 2m squared minus m minus 3 is equals to 0. So what are we doing here? We want to determine the particular solution, right? Not the particular integral, we want to determine the characteristic equation. But firstly, let us determine the nature of roots by factorizing this. The roots of here, we're going to have 2m there. We're going to have m. And then here we're going to have 3. Then there we're going to have 1. Going to negative, going to have positive. So m here, we have 3 over 2. And then m there, we have negative 1. So we have two distinct roots, m1 and m2. So when we have two distinct roots like this, we know that our characteristic equation, it is denoted by this equation of two unequal roots. We have a e to the power of m1 multiplied by x. I'm using x because x is my independent variable, but if I had t over there, I was going to say m1 multiplied by t. If I had w there, I was going to say m1 multiplied by w, but in this case I'm going to say m1 in this case is 3 over 2, right? I have 3 over 2 multiplied by x, plus I have already used a, that means another constant will be b. So I have e to the power of m2, in this case is negative 1. So I have m2, which is negative 1, multiplied by x. So here I have negative x. So it is the characteristic equation. Now this is what I want you to understand. To determine the particular integral, remember we use the trials, right? For example, we can say y is equals to, just like how we did on the first question, we say that we have a e to the power of, let's see, we focus on this side, we have 3 over 2 multiplied by x. This is what we actually spoke about, right, on the first example. So there's nothing wrong with you doing this, but the question is, are we going to get the answer? Are we going to be able to get the value of a when we do the first derivative, the second derivative, we substitute on the equation, we determine? It won't work, right? Or it will work, it depends. So there's nothing wrong with you doing this. You're gonna have to try it and see if it works or not. So if this doesn't work, you jump to the next one, which is y is equals to a. Now we introduce x, which is our independent variable, e to the power of 3 over 2 multiplied by x. And therefore, we check if this works. Are we going to be able to get the value of a? And then if this doesn't work, we jump to, we're doing trials, you understand? So we introduce ax squared, e to the power of 3 over 2 multiplied by x, and then we check if this works. Then if this works, by determining the value of a, we're going to determine our particular integral, and therefore we add our particular integral to the characteristic equation, then we get our general solution, you understand? So here the trick is to play along here. Now remember what did I say to you? I said maybe it will make sense by now how to use that table. Now here's the thing. Which one are we going to use? Are we actually going to use the straightforward case, or are we going to use one of the special cases, in this case, to determine the general solution? Let's see if we're going to use the straightforward or this special case or that special case. So what I'm going to do here is I'm going to help you how to, because we don't want to do trials. Imagine you use this, it doesn't work. You use that, it doesn't work. You're wasting time in exam or in class test or whatever the case may be. So what are we going to do that? So to know which equation to choose, whether it's straightforward or particular, we're going to do this. I said to you, On our differential equation, we have e to the power of 3 over 2x. If this appears on your characteristic equation, therefore we have a special case. So e to the power of 3 over 2x, it is true, it appears on the characteristic equation. We have e to the power of 3 over 2 multiplied by x. Even there we have the same thing. So that means for a fact that this appears on the characteristic equation, we have a special case. Okay, so this example is a little bit the same as example number one. It's a little bit the same as example number one. But the difference here is that here we have e to the power of 4x. But on the characteristic equation, we have e to the power of x. So that means e to the power of x of 4x, it does not appear on the characteristic equation. Therefore, we use a straightforward case. We don't use a special case. That's the difference about this. And instead of you doing those trials, you don't have to do that. Just look at this and you get the characteristic equation. Okay. So that's what this table it is actually explaining, that when we have e to the power of when we just have this and it doesn't appear and this doesn't appear on the characteristic equation, we use a straightforward case. But for a special case, for a snake case, if this, when e to the power of ax appears in the characteristic equation, therefore we introduce x there. You see here we don't have x at all, but there we will introduce it if this appears on the characteristic equation, and therefore will come on the second one. For now, we're just focusing on the first one. So, okay, so it appears, and then this is how it appears, right? This is how it appears. So that means it is straight, it is the special case. Which special case? We're going to introduce only x. So that means we're going to say our y is going to be the same as a multiplied by x e to the power of 3 over 2 multiplied by x. And therefore we know that from here, then we're going to have to derive our equation. So here we're going to have our first derivative. So when we derive this equation, we're going to have to use the product rule. So I know we've been integrating, but also remember your differentiation rules, how to differentiate. So to differentiate this using the product rule, we know that we're going to differentiate this. I'm going to have a over here. And then and this one, I'm going to keep it the same. I'm going to have e to the power of 3 over 2 multiplied by x plus, now I'm going to keep this one the same. I'm going to differentiate this one, which will give me 3 over 2 e to the power of 3 over 2 multiplied by x, close my bracket. So when I further simplify this equation over here, what am I going to get? Make sure you're going to get I'm going to get a e to the power of 3 over 2 multiplied by x plus this multiplied by that. I'm going to have 3 over 2 ax e to the power of 3 over 2x. Now, I'm going to perform my second derivative. So I'm going to take this equation. It's fine. You can, yes, take this to simplify your life, the one that is simplified already. So when I simplify this, here I'm not going to perform any product rule because I can see that I have only one function, which is this, which is exponential. So to differentiate this, I'm going to have 3 over 2 ae to the power of 3 over 2 multiplied by x. We are done. Therefore, let's differentiate this. We can see that here we have two functions. So to differentiate that, I'm going to differentiate this function that has x. So I'm going to have 3 over 2a multiply, when I differentiate this, e to the power of 3 over 2x, I'm going to have 3 over 2 e to the power of 3 over 2x, close my bracket, plus, I'm going to keep this one, 3 over 2ax, then oh, I cannot I did a mistake. I cannot differentiate both of them here. Let's fix that mistake. So that means this one. Oh, I did not. I did not. I thought I differentiated it. I did not. So it's 3 over 2. It's fine. So that means here, after I differentiate this, I keep this one the same. Supposed to be like this. Yes, it's fine. Supposed to be like this. Right? It's supposed to be like this. Let's not make mistakes. We have a long way, so we can't afford to make mistakes. So this one, I'm going to keep it as it is. And then I'm going to differentiate this. I'm going to have 3 over 2 e to the power of 3 over 2 multiplied by x. And then when I further, let me just write it at the below here. When I further simplify this, I can see there I'm going to have that. And I have that. So this one, let's see. This one is 3 over 2 AE. I want the one that has AE as well. This one's going to be 3 over 2 AE as well. It's going to be 3 over 2 AE. And then when I add them, it's going to give me 6 over 2 is going to be 3. So I'm going to have 3 AE to the power of 3 over 2x. And then this one, when I multiply them together, I'm going to have 9 over 4, right? So that means I'm going to have 9 over 4 a 9 over 4 a x e to the power of 3 over 2x. This will be my second derivative, right? So I have my first derivative, I have my second derivative, and I have my y, which I'm going to have to substitute onto this equation. Second derivative, first derivative, and my y over there, I'm going to have to substitute. So when I substitute second derivative, where I'm going to have to multiply 2 by 3, over there I'm going to have 6, right? I'm going to have 6 a e 3 over 2x, and then I'm going to say 2 again, multiply by 9 over 4, it will give me 9 over 2. 9 over 2 a x e to the power of 3 over 2x. Right? Now I have a negative there. I'm going to substitute my first. Where is my first? Here's my first derivative. I'm going to substitute my first derivative over there. So that means I'm going to have negative a e to the power of 3 over 2x. And then negative, right? We still have negative. And I have to multiply negative 3 over 2 over there. We're going to have negative 3 over 2 a x e to the power of 3 over 2 multiplied by x. Right? Therefore, we have 3 multiplied by y. So where is y? 3 multiplied by y, that is y. We're going to have negative 3a x e to the power of 3 over 2x is equals to 5 e to the power of 3 over 2x. Right? So this is how we go about for this question. Now we are not done. Remember, we have to solve for value of a. Right? We have to solve for value of a. Now let's see how to go about here. Which are the like terms, which are not the like terms. So this side, we have only AE, here we have AXE. So this and this, they go together, and that one as well. So we're gonna have 3 minus, because the denominator is the same as 2, so we're gonna have 3 minus 9, right? So 3 minus 9 is gonna give us 6, and then 6 divided by 2 is gonna give us 3. So this, and this, they're gonna cancel out, right? And therefore we have 6 minus 8. And then 6 minus a in this case is going to give us 5a e to the power of 3 over 2 multiplied by x, which will be the same as 5e 3 over 2 to the power of x. So this cancels this cancels that, and then we can see that our value of a will be equals to 1. We divide everything, we divide by 5e, it's going to be 1, right? Now that will be the value of a. Then we go to our characteristic equation. Particular integral. We're gonna say our particular integral. It's gonna be a is 1. So that means we have 1 multiplied by x e to the power of 3 over 2 multiplied by x. And then our general equation in this case, remember we have the characteristic equation, which is a e to the power of 3 over 2x plus b multiplied by e to the power of 3 over 2x. Oh, subtract x. Here we have negative x. Okay, let's be careful. We have negative x plus particular integral is going to be plus x e to the power of 3 over 2x. Therefore, this will be our general solution, unless if we have the conditions. Stay tuned for the next upcoming question.